Hello, my name is Xander. Welcome to Very Academy. This is a theory session. Here we're looking at web servers versus application servers. So essentially, we're going to discuss the differences and roles, characteristics of a web server in comparison to an application server. So I am making the assumption that you are a beginner or you're new to web development, but you do have some basic understanding of, for example, what is a CPU, what is RAM, for example, so basic computing principles. In this tutorial, I'm going to take you through a story whereby we slowly build up our knowledge to a point where we can better understand the characteristics and roles of a web and application server. Unfortunately, this is a type of topic area which you do really require some underpinning knowledge for you to fully understand or start to understand the role and purpose of a web server in comparison to an application server. It's always going to be the case that I'm going to say something and infer that you understand it. If that is the case, then you can leave comments in the video and I'll try and help and support you. Ultimately, I do want to give you enough information and present it in a way which hopefully enables you to further engage with other materials on the subject matter. Let's imagine we're building a new business and we need to start off building some online presence, building a simple website. So what is a website? A basic website. So a basic website consists of files, and that might consist of HTML files. It might consist of CSS styling code to style the HTML, and it might include JavaScript, and also it might include images and video. So essentially all we're talking about here are files, individual files. These files are going to be stored on a server, which is a computer essentially with CPU, with a RAM, and has some sort of permanent storage device. Now, our files are going to be stored on this hardware, and they're going to be stored on some sort of storage device. So all that we're trying to do here is we're trying to make these files available to anyone who wants to visit our website. So to have a website, typically we're going to have some sort of domain name. So we're going to purchase a domain name, whatever that might be. So let's just go for shoes.com. So we're going to build an e-commerce store here. So a user would type in shoes.com and then that would get resolved via a DNS server. Essentially what's happening here is that in order to send messages across the internet, we need an IP address, and that's the location of our server. So a DNS server will translate the URL that we type in, the domain name, sorry, that we type into our browser into an IP address. And that IP address is the address, like a telephone number. We need to know the telephone number in order to ring someone, to contact them specifically. So we need to know the IP address of this server to access the files that correspond or relate to the website that's going to be then rendered into the browser. So we type in this domain name here, it goes across the internet, and eventually it finds this server. Now, by default, this server will serve a file called index.html if we don't type anything into the URL after the domain name. So that's the first page that gets served. So the index page here gets sent back all the way across to the browser and is rendered in the page. Now, to render that page, to actually produce that page on the browser, maybe that page does require other resources like images and video. So your browser can make additional requests for this data, but ultimately it's just making requests. And the type of requests that it's making are HTTP requests. So this is going to send, the browser is going to send HTTP requests across. And a HTTP request is a way of sending a message so that the server can understand what it is that the browser requires. And within this HTTP request would be information such as maybe what resources that we're looking for to then send back. So this is a basic setup here of a website. So hopefully we're all on board so far. So I've just removed some of the different images here to make it a little bit more simplistic. Right, so in the browser, we type in a domain name. That's going to send a HTTP request over for the resources that correlate to or correspond to our website. Right, so This server is just a piece of hardware, right? So it has a motherboard, it has RAM, it has a CPU, like any computer, but typically servers may be more powerful than your typical computer at home. So this server is essentially hardware. Now, to actually intercept and to respond or to actually process this request that's been sent from your browser, then we're going to need software. So I've expanded the server now, so this box represents the server. So we send a request from the browser. Now the internet uses port 80. So think of a port as a doorway. So in our HTTP request, we send this on, which we describe as port 80. So this message goes into the server, and the operating system then identifies this, potentially through the fact it's utilizing port 80 as internet traffic. So what we have on the server is another piece of software, which we can describe as a web server. And this piece of software is designed to manage and process HTTP traffic, HTTP requests. So there is plenty of different HTTP web server software out there. Some of the biggest software include Apache and Nginx. So we now know that the web server or HTTP server is essentially just software that will be installed on the server, which will provide a service to the browser to basically collect the correct files from the file system on the server and then return it back to the browser as per HTTP request. So for example, if we were to send a request to this location, shoe1 for example, that request here, and let's go for .html. So this request will be sent across to the server. The operating system will handle the fact it's from port 80, so it sends it across to the software that's installed, the web server that's installed in the server. Now the web server reads the request, and it can read the fact that the user is trying to access shoe1.html. So it then looks into the file system in the correct place for that particular file, and then it sends it back. So what I've just described to you is the essence of a web server. Now there's some different terminology here which we can now bring into this. So you may have read through some other guides discusses something called static content. Well, this here can be described as static content. This file index page, this about us index page, this video, this image, this can all be described as static content. This is content that doesn't change. It's not dynamic. There's no changes potentially. Yes, you can change these files, but there's nothing that the user can do to interact with these files to make any changes. These files are set, and they can be changed and edited, of course, but they are set and then simply just served back to the users. Therefore, they are just static content. So typically, static content includes HTML files, it includes CSS files, and JavaScript files can also be considered as static content, which can be just simply passed over to the browser. So let's imagine we wanted to actually purchase our own server and to configure this in our own server. Now, this is just one of many ways we can host our website, but let's assume that we want to do that. And that enables us to better understand a little bit more and lead us into application service. So we want to purchase one of these servers online, and we can do that through many different providers, Amazon, Microsoft, Google, and there are other providers. But just look at some of the different dynamics here when purchasing a server, and that'll help us understand a little bit more about this setup. So this is DigitalOcean. I'm not sponsored or anything here. It's just one of many services. So let's just go to their products, and we'll have a look at a Droplet, which is essentially just a server that we can utilize and install software onto it. So we can install a web server onto it, and we could then also place our web pages onto it, and we could then utilize it as our web server. And notice that these start from maybe $5 and they can go up to hundreds of thousands of dollars. So they scale exponentially. Let's have a look at the pricing. So this is a simple server. So Droplet, just change that to the word server. You can see here that for $5, we can access a server or purchase a server which has 1 GB of memory, and it has one CPU, and it has 25 gig of RAM. 25 gig of storage, and then also transfer, referring to the amount of data that we can send out per month, 1 terabyte. And you can see here that the more that we spend, the more hardware that we get. So if we spend $10, we get 2 gig of memory, and we still have 1 CPU, but we have 2 terabyte transfer, and we have a little bit more storage. So there is a correlation here between the quantity of users, of clients that are trying to access our server, and the amount of resource that we require to serve those requests. So if we have one user just accessing our web page every couple of minutes, then we're probably only going to need a smaller server. So what I mean by that is that the resources that we need aren't going to be necessarily as much as if we had multiple users connecting. I probably could explain that a little bit better. Apologies. I hope you get that. So if we just have one user accessing our server, our CPU will be powerful enough. We'd have enough RAM, and obviously our hard drive will be able to serve these files very easily. So once we start scaling up here, say if we had 1,000 or 5,000 users per second, for example, the more users we have, the more requests the server is having to process. And then the more the server needs to process, the more CPUs are going to be needed, because eventually what's going to happen is that we're going to have a higher amount of traffic. We're going to have too much traffic trying to be processed by our server with a small amount of hardware resource. So the CPU can only process a certain amount per second. Imagine this data is stored on a hard drive. So this server needs to find this data, retrieve it, and then send it back. And that takes processing power, that takes RAM, and that utilizes RAM. So there's a correlation between the amount of users that's trying to request this service and the hardware that's required in order to support those requests. So let's imagine that our service has become very popular. So we have a few different options here. The first thing that we can do is that we can do something called vertical scaling. So this is something, a terminology you might see in other examples of comparing web and application service. So we have something called vertical scaling, which is essentially just purchasing more hardware. So we can characterize vertical scaling as a way of making a much more powerful server. So one single server, potentially, we just make it more powerful. So we have more memory, we have more CPUs, we have more hard drive space if needed. So that's vertical scaling. We also have something called horizontal scaling. So this is slightly different. So what we do here in horizontal scaling is we essentially just copy this and we purchase more servers. So when we do this, for example, potentially we'll also need something to kind of manage where this data goes. Because what we're trying to do here is we're trying to distribute the amount of connections that are coming into our service over multiple machines. And by doing that, we're harnessing the hardware of all these different machines so that we can actually then support the amount of users or the quantity of requests that we receive. Now, this is typically typically managed by a load balancer. So we have some sort of intermediary device or hardware here or service which we can purchase or set up ourselves, which will load balance. Basically, what this is going to do is it's going to take in the requests, and then it's going to divide those requests up into the different servers here. So essentially, we can now support more users per second or more requests per second because we're dividing that up into multiple servers. Now, a typical characteristic that you read about web servers is that the resource utilization is low. So there isn't actually much resource needed to simply process a request and just send back a file. Now, in the grand scale of things, that's correct. And when we look at the application server, we'll see how that's slightly different. So here we can say that the resource utilization is low because all we're doing is this server here is basically just taking in a request from a user and it's just processing it. And that isn't going to take up too much processing of your CPU to do that. Once we start scaling, it will obviously scale and take up more CPU time. But ultimately, in comparison to, for example, the application server, the resource utilization will be fairly low. So it will be fairly cheap to serve multiple requests per second. So another characteristic that you may read about the web server is that the web server mainly supports HTTP or HTTPS protocols. So what that means is that we send a request from a browser. That request is typically a HTTP, or if we're using a secure version, HTTPS. So we're using those protocols, and that protocol defines a set of instructions on essentially how to communicate with the server. The server understands that protocol, so it then is able to communicate or utilize that language, that format of data to then process it. So the web server, this piece of software here, basically is designed to do that, and it can do that very well. So the web server characteristic generally it mainly supports these protocols. It doesn't mean it only supports that, and this is where it gets a little bit muddy because web servers are very powerful and diverse software. Is a very powerful and diverse software which can support other protocols. But for the purpose of comparing this web server to application server, generally we say that the web server mainly supports these basic protocols. So over time, the requirements of our web pages, web services have changed. So at the start of the web, typically this is a setup that you would find. We would have simple static web pages being served to the browser. Now, like I said, over time, services have changed. We went through Web 2.0. We started to see more interaction on web pages. So more interaction required different resources, a different set of tools. And that's where the infrastructure potentially changed and where we started to see this idea of of application servers, So going back to our scenario, our shoes.com, we now want to get a little bit more serious because we found that our service has become very popular and potentially we could make money by actually building an e-commerce store. Now, an e-commerce store might include lots of dynamic elements. So, for example, it might allow interaction from customers to leave reviews. There might be some sort of help desk with some live communication between customer and employees to be able to discuss different issues. There may be some sort of email service that needs to be provided. There may be other potential services that we might include. We might have some live events for advertising different products. So there's a whole host of different dynamic services now that we want to provide. So here's some big decisions that we need to make because we need to now think about, well, what kind of setup, what's our stack, what technologies do we want to use now? So in the back end here, we could use Java. We could use .NET, we could use Python, we could use Ruby, we could go for a pure JavaScript approach. So there's lots of different options here that we can decide, we can choose from when we're thinking about now making a more dynamic, interactive website. So if you've seen other content on this channel, you know that I'm going to choose Django. So Django is a web framework, and I will introduce other frameworks and give you other examples. But here we're going to utilize a web framework, which is essentially a base for us to then build a website. It is written in Python. So we've decided to utilize this tool now to build our dynamic service. So let's just move that out. So now what we have here is we're going to go ahead and we're going to install Django right here. We'll go ahead and develop that application. That it is connected still to some templates here, so to some static data. So Django is kind of connected to that. Hello. didn't work. Django does require some static content, but the issue we've got here is that if we wanted to utilize a framework such as Django, which is essentially just Python, or whether we wanted to use Ruby or .NET or Java, the problem we have here is the traditional web server that we mentioned earlier, whether that be Apache or whether that be Nginx, it cannot directly communicate with these type of frameworks and languages. And so therefore we need some sort of intermediate server which is going to translate these requests into something that these programming languages can understand, so that they can then go ahead and serve these web pages back to the browser. So for example, if you were to utilize a Python backend here, whether it be the Django framework or not, then the likelihood is you're going to need some sort of, which can be described as an application server. So if you're using Java programming in the back here, you might use Tomcat. If you're using .NET in the background, you might use IIS. If, for example, you've chosen to utilize Ruby, then you might use Unicorn. And here in Django Python, potentially there's a few different options, but here we have a piece of software called GUnicorn. So let's go ahead and add this to the mix here. Okay, so this is essentially an application server. So it's just a piece of software which is going to take in requests from our web server, and then it's then going to forward that data over to Django in a way that it can communicate with Django, and then Django is going to do its thing and then serve back the relevant information to the user. So to avoid confusion here, I've just changed this to Python. So here we're just discussing the idea of building an application in Python. And the idea is that we can communicate, or we can accept requests from users through this intermediate piece of software called GUnicorn, which we can describe as an application server. Okay. So we're starting to see this general idea now of web server and also application server, in this case GUnicorn. So I'm going to change this to application server so that we can kind of differentiate that. So at the moment we're just talking about software here in these two elements. Remember, although we're using the word server here, server describing the fact it's providing a service. Right, so the reality here then is that this can all be run on one server. Okay, so this web server package software, this application server software, it can all be run on one server. So we could just describe this as a web server. So that's where some of the complications, or where it gets a little bit muddy, in that it's very easy for us to package everything up in one server. And we can't call this a web server. We can't really call this an application server in its own, because it's kind of both, because we're essentially running the services that characterize a web server and an application server in one piece of hardware. Okay, so let's just forget about that. Let's just talk a little bit about what's happening now. So we've gone from a simple static website where we're hosting all these files, and we've now created this website utilizing the Python language, which provides all these wonderful interactions. So the user is now allowed to log in, they can access products, they can buy products, they can speak to the help desk in real time, they can do a lot of different things now. Now, all these different services requires different resources in the background, and one of them is going to be, for example, a database. So potentially we're going to need to spin up a different database, spin up a different server, and we don't have to, it could be on here, but this is now going to be connected to a database to make our content a little bit more dynamic. And that means that although we still have these static pages here, what actually gets presented on those pages or prepared on these pages might be different per user. So what I mean by that is that imagine we had a page here called products. Okay, so that is a page that it gets rendered in this browser, which shows all the products in the database. Now let's imagine that for example, this user wants to see all the red shoes. Now that's still going to be served from this page, but Python is going to dynamically determine what page the user is looking for, and they're looking for the red shoes. And then it's going to grab from the database all the red shoes and place that data onto this HTML template and then send it back to the user, thus making this setup dynamic. Now you can already see that there is a lot going on here in comparison to the previous setup where we were just serving static web pages. There's a lot more processing taking place. In addition to the web server passing data across, the application server is also processing that data. But in addition to that, like I just described, back here, the Python code is actually then performing some other processes. Now, these processes can be described as business logic. So the idea of business logic is utilized quite a lot in other examples when explaining web and application servers. So just think of business logic like I just described here. In order for their business to work correctly, this user had selected the red shoes, and that might be different from someone else. So you imagine on this page, there's a filter, and the user can click on the red button, and that then only shows the red shoes. So that's potentially part of the kind of business logic here, or domain logic. It's part of the program whereby we set rules and we then determine how that data is then changed so that we can then send it back to the user. But likewise, we're going to need some potential business logic because the user needs to sign up to the service. We're going to need multiple users. We're going to need admin users, and we're going to need customers. So there's different types of users, and all that logic needs to be prepared and ready to run correctly behind the scenes here so that the web page acts accordingly. So hopefully I'm building up a bigger picture whereby you can see that there's a lot more going on now. So typically, this requires then more processing. Now, we've already mentioned before that one of the characteristics of the web server is that it has generally a low resource utilization. And hopefully we can see why that is now. The web server simply just passes data across and grabs data from static files and sends it back. Whereas this new application server kind of setup, it involves a lot more processing potentially because it takes a lot more processing to process requests from the user and the data they require, and then to prepare that onto templates to then send back, in comparison to just sending across or directing HTTP traffic. So eventually, one server potentially isn't going to be enough. So potentially a good way of structuring this is into some sort of layered system. So you may read through this idea of 1 or 2 tier applications or 3 tier applications. So what we can do here is we can split up this infrastructure potentially and separate the web server from the application server. So now we got into a situation where we split up the web service, or the web server, and the application server, and where that resides into separate servers. We may have a separate server for our database as well. So we now have three servers here. Right, so here we can start to see that we've now differentiated the web server and the application server. Now, although we're still here just talking about software, because the software is installed on this server, we can then go ahead and describe this as the application server because it's solely designed to run this application service here, this software, and this service. And the web server here is still doing the same role as it was before. It's handling the HTTP requests, and this is passing them across to the application server and this software here. So it can then be handled by and work with the underlying programming language that's being utilized to actually run the website. So there's a few different benefits here. Because we spoke about earlier the fact that the web server is a a low utilization of resources, it means that potentially, if we go back here to Droplex, maybe we only need to spend a small amount of money on this. So we buy a smaller server. So that can easily handle then millions of requests, say, per second. So the application server, in comparison, that's probably going to need a much larger resource for it to be able to process the larger amount of information, potentially the bigger overhead of information. So we can say that the resource utilization here is higher than the web server. So same principles applied we mentioned earlier. So we could scale this section here horizontally or vertically, depending on how we want to set this up. So we could go ahead and create multiple versions of this and have some sort of load balancing situation. But ultimately, we don't necessarily need to speak about that. Hopefully you get the basic idea now of some of the differences here. So the web service here is still serving static content, but the application server is providing services to an application that is the main component of delivering or preparing the website to be then served back to the user. So you might see in other examples that in actual fact the browser can communicate directly with the application server. So there's not necessarily any real need for this web server actually having Nginx or Apache here to kind of just forward this across, because in this type of situation, this web server here might act as something called a proxy server, which is essentially just pushing data across over to this application server. Now, this application server, in some cases, can support HTTP and other protocols. Right, so this could actually just be your main server, so you could get rid of this web server software and you could just use the application server. But the application server is generally more designed and geared up towards serving applications, whereas here the web server software is geared up towards HTTP traffic, which is generally the protocol that's utilized in this type of scenario. So let's just establish that a little bit further. Here I've named these servers now. This is the web server. This is the application server. So the characteristics here is that the web server is running a web server software and the application server is running application server software. Now, I said previously that both the web server software and the application server software, they can both handle HTTP requests. However, it's just generally considered that the web server typically might also still be handling static content, and the web server software is best at doing that. So in addition to actually having all this processing and preparation of data and business logic here at the back here in our application server, the web server can still serve static content. So that might be style.css or JavaScript files. So we could probably break this down further in a more simplistic way now. We could say that the web server is just hardware. When we just describe a web server, we could say this is just hardware. And inside of this web server hardware, we have a web server software, or we have HTTP server software. And this software is designed to handle HTTP traffic, to process HTTP traffic, and then potentially also to serve static content back to the browser. In comparison, the application server, again, is just a server piece of hardware which can be scaled like the web server, which has software installed. And that software might include an application server, and that's a piece of software. So similar names here, but hopefully I'm differentiating that enough for you to kind of understand that. So it has application server software, and that software is designed to handle requests that might be HTTP or other types of requests, and then to be able to translate that and communicate with software, other software that's installed to provide a service to a client. So the main difference is here we have static content, and here we have an actual program, an actual application, and that makes things a whole lot more dynamic. And I think that's the key here when you're trying to compare a web server and application server. Application, it's kind of in the name. There is an application here which cannot be directly communicated via a browser. Therefore, we need a piece of software which can communicate and handle the requests and send the data back to the client. And that could be a browser, that could be other software. So let's put this to a test. Web server versus application server. Let's have a look at the top answer here. Hopefully this includes a nice little list here. So of the differences. So I think we've covered everything here. Hopefully this now, what I've said makes it a lot easier to understand this, or we can relate this to it. So a web server delivers static content. Hopefully I've explained that. It delivers HTTP protocol only. Hopefully I've come to made you start to understand that if you didn't know what HTTP protocol is. You may need to do a bit of reading here. So the HTTP protocol. So we're just talking about a set of instructions that allows the client to send a message from the browser to the server. And because it's a protocol, because it's a set of instructions, both ends of this communication understand how to communicate through this set of instructions. So that's a HTTP protocol. Serves only web-based applications. So here we're just talking about static pages, and there's no support for multi-threading. Okay, so multi-threading we don't necessarily need to talk about here. It's a bit of strange, in my opinion, putting this here, but I understand why this is, and this is arguable. So multi-threading, the ability to do maybe more than one thing at once. When we talk about applications, applications can be designed to process or to manage things concurrently. So the idea of a web server basically takes the request and then it deals with that request, and then takes the next request, deals with that request, and so on. And there isn't necessarily any kind of concurrent actions happening at the same time, whereas an application would be designed to maybe support multiple users at once. So facilitate web traffic. That is not very resource intensive. So the idea that the web server basically just deals with HTTP traffic, processes that, and the processing for that is very low in comparison to if we're running an application. Okay, so for the application server here, delivers dynamic content. So the idea, it's an application. So the user can make additional requests. They can log in, they can request and from their own requirements, what it is they want. So I gave you an example, they want the red shoe or the blue shoe. So it's dynamic. What gets served back to the user is dynamic based upon the user's needs and requests. That, of course, is in comparison to static content, which is just static. So this idea of providing business logic, it's an application. So on the application, we have application server, we have an application. So it is designed and built with high-level programming languages that we can then design logic and instructions so that we can fulfill business logic. So here we're just talking about how we want maybe people to be able to interact with our business and how our business should react based upon interactions from the user. So something we didn't mention here, the application server is not just about web. So there are other types of services which I haven't mentioned that can be provided from an application server. A simple example would be an email service. So Google Gmail, for example. So that is an application behind the scenes. And we might use different protocols to kind of interact with that. So we mentioned multi-threading and supports multiple requests in parallel. So an application can be designed to do that. Or the language can facilitate that and facilitates longer running processes that are very resource intensive. Yeah. So the web server, remember, is just static content. Here's the content. Let's grab it. Let's send it back to the user. That's all. Whereas an application, obviously, is going to maybe process based upon different requirements. There's a need for data in a database. Maybe it needs to process a request. So, for example, the user might request to process, for For example, they want to resize an image, so that needs to be processed, for example. So the application server has an application which is going to deal with that request, and that might have a long running process. So for example, we may, from the front end or our client, they may request all the data about a particular user in a particular certain time. So the application sends a message from the application server to the database and then deals with that data. And that can be a long running process to return that query. So definitely don't overthink this. An application server has an application that's been built to provide a dynamic service. A web server is just a static type of process. We have static elements, artifacts here that are just served back to the client. Okay, so I hope that was useful. Hope you've learned something there. Hopefully I haven't embellished or gone on too long there. This is version 1. I would definitely do a version 2 and improve upon this maybe in the future, depending on how popular this is. Thank you very much for listening, and I'll see you in the next tutorial.